So cool. Hello and welcome back to Physics Chat. I'm Susanna and I'm back with my lovely co-hosts, Joe and Sergi. Did you miss me? Sorry I couldn't make our last video, but thank you, Sergi, for hosting the last Physics Chat. It was so interesting hearing from Daniela. But on today's show, we have another amazing postdoc at the Institute of Cosmology and Gravitation, James Trayford. Hello, James. How are you?
Hi, Susanna. I'm doing well. How are you?
I'm doing great, thanks. Thank you so much for being on the show. It's honestly lovely to have you here. And James is currently researching galaxies and galaxy formation. But first, it's time for my random question. So, James, what music are you listening to at the moment?
Yeah, that's a good question. So, the last thing I bought was an album by this guy, LA Priest. I really enjoyed that. I've been listening to Mitski album, the new Mitski album, Squid. That's been in rotation. Lots of new stuff actually.
Nice. That sounds really cool.
Yeah, I also listened to the last album by Mitski and I really liked it.
Yeah.
But I hear you have been making music from scientific data. So could you tell us a bit about how that works?
Yeah, so this general idea, this idea of taking data and converting it or conveying it through sound, we call sonification. And you can think of this a bit like visualization, right? It's like we're used to making graphs or images and displaying data that way. But maybe we could equally convey data through sound. So there's a few reasons why we might want to do this. So one of the big ones is accessibility. So, in astronomy, we lean pretty hard on these incredible images we can make, distant galaxies, stars and planets. These all look amazing and it helps to draw people into astronomy. But the flip side of this is that it's also kind of exclusionary. If you can't see these images, then you're not being invited into astronomy in some kind of way. So we thought, can we convey the kind of beauty, the kind of complexity of this data using sound instead? And there's also the idea that there might be specific advantages to sound. Your ears might be better at certain things than your eyes are. Your ears are very good at hearing difference between different rates or pitches. You can hear in 360. So I think for most people, you can only see what's in front of you, right? And it also can help you can hear over like a very large range in frequency compared to what you can see, the window that you can see with your eyes. So there's all sorts of advantages, I think, to trying to do this. And it helps for me because, someone who likes music and sound and playing with sound, it's great to just kind of stuff your niche hobby into your niche day job and be able to do them both at the same time.
Brilliant.
Yeah, that's so cool that you're making science more accessible in this way. Do you have any interesting examples to show us?
Yeah, so perhaps, so recently this started as something kind of just playing around and then became more and more serious. So I've been collaborating with Nick Bond here in Portsmouth and also a guy, Dr. Chris Harrison, up in Newcastle. And we did this Audible Universe planetarium show. So the idea of this was it was the first planetarium show aimed at visually impaired children. So all of the examples you could hear, and there were visuals for the whole thing, but the idea was that even if you couldn't see any of the visuals, you should be able to get everything across through the sound, through the sonification as well. So one of the examples of this was our stars appearing. So the idea, is one of the maybe people's first introduction to astronomy is to go out on a clear night and look at the stars. And you see that a few bright stars first, and as your eyes adjust, maybe you see more and more. And if it's a really clear night, you're seeing all this really detailed map of stars above us. And obviously that's not something that's accessible to people with visual impairments. So what we tried to do was to take this idea and have sound represent when stars appear. So you hear the brightest stars first, you just hear a few, and these are placed all around you in space as they would be in the real sky. And you're hearing them get more and more frequent as dimmer and dimmer stars come out. we also try and encode the color of stars in the sound as well. So the pitch is related to the color of stars. Redder stars are deeper and bluer stars are higher. And this kind of mimics the fact that bluer light is higher frequency than red light. So in this way, we're trying to get across the beauty of the night sky, but also make something that sounds good while also getting across the real data.
Can I just say, you are amazing. And I had the opportunity to try this and it is so flipping good. And I totally recommend listening to it. Sergi, you also had the privilege of...
Yeah, I had. And yeah, it was amazing.
Yeah, it's great to have you try it out. And so as I said, we did this planetarium show. And the next step was to actually try and do this in VR. So then, this is kind of more maybe in certain ways personally accessible. People can just get access to a VR headset and try it out themselves. And it's really fun to have people try it.
Like you're going through a cloud of what's he called it? Candy floss.
Yeah.
So good. It was so cool hearing all the stars come on and hearing them you could hear them 360, couldn't you, Sergi?
Yeah.
It was so cool.
I think I have seen the clip as well, and I just loved it. Starts quite random and kind of blends together into this really nice sound. But just to check, James, so when we hear all these stars coming out, are they quite close to those? Are they like were the closest ones? How big a range and whereabouts are these stars that we're hearing?
Yeah, so that's a good point. I mean, it's kind of a bit of a mix, but generally the loudest stars we hear are pretty close to us. And you're hearing a kind of range of, from really bright giant stars to kind of pretty typical main sequence stars that happen to be very close to us. So it's this kind of mix of how bright things are and then also how far away they are. And like you say, when it starts, you're just hearing these few stars. So you really can pick out individual stars. But as the night goes on, or our example goes on, you're hearing more and more and more. And it eventually kind of blends into just a kind of continuous sound in some sort of way, which is, very similar. I think it kind of gets across this idea of what stars are in our Milky Way. We see stars around us, but also the galaxy, the outline of the Milky Way that we see in the stars appearing example is just an outline, that's kind of continuous light that's made up of billions of stars, right? That blend to make one structure that we see, basically.
Yeah, really interesting to hear about. But what about other galaxies? What do we know about stars in other galaxies, and are they the same? Are they different? What's it like?
Yeah, so starlight is kind of crucial, really, for understanding other galaxies. In fact, starlight has for a long time was more or less the only way we could learn about other galaxies. By learning about stars in our own Milky Way, we can get some insight into what these galaxies are like, because this starlight encodes all sorts of information. So the color, for example, of stars tells us something about the age of the populations of stars. So if it's bluer, it could tell you that there's more recent star formation. It tells you something about how the galaxy's forming. And also, if you look at very specific shades of light or individual frequencies, you can learn about different chemicals in the stars themselves, so different elements that make up stars, so how the composition of those galaxies came to be as well. So taking all this together, using starlight, you can really try and build up a picture of this formation of a galaxy.
Yeah, I assume, these galaxies, this huge collection of stars, didn't just pop into existence from nowhere. So how do they form in the first place?
The formation of galaxies, is something that's like an open question in astronomy or astrophysics. So, I mean, really, the standard picture at the moment starts with the formation of structure itself in the universe. You go back to the very early universe and you've got this kind of hot, dense medium that's very uniform. But as the universe expands and as gravity does its thing, this material starts to collapse into structure. So you start to see sheets and filaments and eventually halos, which are these kind of the densest parts of the cosmic structure. And in these halos, we think that essentially gas can fall in, collapse, radiate away energy and form this kind of dense gas in the center of these halos. And this would be the sort of proto-galaxy from which the first stars can form. And then after these stars begin to form, galaxy formation is an ongoing process for billions of years. To build up something like our Milky Way, it can take billions of years of this star formation and other things happening to get a galaxy like our own.
Amazing.
Okay, so James, can you tell us about the biggest question still unanswered in your field, and how does the future plan to answer it?
Yeah, that's a tricky one because there's so many questions, but I suppose generally the idea that I'm excited about is to test really, whether our picture of the earliest galaxies in the universe, really the first forming galaxies, is accurate. And the way we can do this is with these like new facilities like the JWST, which will be able to peer even further back than ever before into the early universe and really get detailed imaging of these galaxies. So we can really look at these kind of weird and wonderful things in the early universe. And there's an amazing picture actually recently, a calibration image, which was the first thing to come from this telescope, which launched at Christmas. If you're cool on Christmas, you were watching the telescope launch, right? And it's basically just of a star. It's just to calibrate the image. But if you look in detail, you can see all these incredible galaxies just in this one field. And it's just really tantalizing to think about when this is actually, trying to image galaxies, how good it'll be.
Thank you so much for coming on to Physics Chat and for sharing with us your amazing project about hearing science. Who knew stars had a sound? And I absolutely love it. And by the way, James has a website. And if you want to listen to scientific music, please click the link in the description. And he has a planetarian show, which is on his website. So check it out. Please do. It's honestly amazing. Let us know in the comments section what music you're listening to at the moment. Joe, what music are you listening to at the moment?
So there's a band from Manchester called Everything Everything, who kind of, I don't know, you call them electronic synth rock, but they've got a new album coming out very soon. So I'm excited about that.
Nice. And Sergi, what about you?
I'm not prepared for this question now. I like to listen to different types of music at the same time. But if I had to say one, I also enjoyed a lot the new album by Mitski. So yeah, I'm going to say that.
Well, again, thank you, James, for being on the show and just chatting with us. And thank you again for joining us. And we hope you have a great day. And bye.
Bye.
Hi, everyone.
Yes, you said it together.
It's great to just kind of stuff your niche hobby into your niche day job. Let me give you the hands.
Ooh, yeah. What is that?
We might have the same head size. So okay. So you can see what's going on, right?
Oh, that's so cool.
Yeah. So this is just the video player. Video player.